All right, we will begin now. Thank you again for all of you who joined today for the webinar Boosting Building Efficiency, Unlocking EPC Gains with BACS. My name is Gusko Sovic, and I am the Managing Director of the European Building Automation and Controls Association, or for short, eu.bac. It's a pleasure to welcome you all to this important discussion on how building automation and control systems can play a transformative role in improving energy efficiency across Europe. As many of you already know, the urgency to meet the climate goals and improve energy performance has never been greater, really. And buildings are a significant part of this aim. With policies like the Revised Energy Performance of Buildings Directive setting ambitious standards, we believe that BACS can not just enable the decarbonization, but also achieve further goals to improve building comfort, smartness of buildings, and connection to the grid. Today's agenda is designed to inform, inspire, and engage all of you, I hope. We plan to start with Marco Marini from DG Ener, who would share the EU's perspective on energy performance priorities for the Commission. However, he's having currently troubles with connecting to the GoToWebinar platform, so we'll try to resolve that. In the meantime, we will actually start with Leonardo Mondonico from Politecnico di Milano, who is part of the team who are the authors of that we're launching today. And he will present the key findings of how BACS can unlock the EPC gains. Finally, we'll have a panel discussion in the second part of this session with diverse industry voices, which will be moderated by Balzerini, the chair of eu.bac advocacy group, and from our member Danfoss. We encourage you to actively participate today, so feel free to use Q&A. We will inform you in the next slide as well how to join the Q&A session through Slido, and also how you can participate in the polls. We'll do our best to address questions you might have in the final part of the session. And without further ado, I will move on to the housekeeping rules for just a few things. The audio and video, so all the participants are muted and cameras are off by default, so the attendees will not be able to participate through audio and video. However, you can join the Slido platform using the code you can see 4270740 or scanning the QR code that you can see on the screen at the moment. You'll be able to use the Q&A function through Slido, and we'll pass on these questions to our moderator, Gaia, so she can address them together with the other panelists. Additionally, we'll also run a few interactive polls and word clouds through Slido. So again, encourage you to already scan the code now, so you're already on the platform and can engage immediately on there. The section is also being recorded, as said in the registration page. By registering and participating in this event, you've agreed to us sharing any discussions and questions of this session also after, and also we invite you to engage with us on LinkedIn, where we'll also be streaming this event and releasing it afterwards as well. So you can find us at LinkedIn by just searching for eu.bac. So before we start with the presentations, I'll launch the first Slido word cloud, Slido poll, just so we can test out the system, and you can also inform us from what kind of organization you're coming from. So the question is what kind of organization you represent. The options are public sector, policymakers or regulatory body, academic or research institution, building owner or facility manager, construction or real estate developer, industry association or NGO, energy building automation or other technology company, a consultancy, standards and certification entity, or other. So we'll give you about 30 more seconds to respond. Looks like we have the industry represented here mostly. We have some public sector participants as well. I wonder what's under the other, and some research institutions as well. Less people from the construction or real estate industry. All right, I can see that around half of you have replied at the moment of the attendees, so perhaps a few more seconds. All right, we'll stop it there. Sorry, I wanted to still keep the results. Right. So majority from the industry, so both from building automation and other technology companies. Then we have the public sector and policymakers and regulatory bodies here as well, which is great because we'll be talking about implementation of the EPBD. So our industry association and NGOs present, research institutions, some construction or real estate developers, and others as well. Thank you for taking part in the first poll. So let me get back to the slides. So as said, initially we wanted to have Marco present first. Do you know if Marco has been able to join? Not yet. All right. So we'll move on to the second presenter. Apologies for this. We'll try to get Marco on right after. So we will start with Leonardo. Let me just arrange the slides here. Right. So we'll start with Leonardo Mondonico from Politecnico di Milano. As I mentioned, he is a part of the team of energy and strategy team at the Politecnico di Milano, specializing in energy efficiency, renewable energy markets, and sustainability technologies. He's led an impactful research on green hydrogen, biofuels, industrial decarbonization, and EU building stock energy performance, with findings presented at high-profile conferences. His background includes consulting roles at BIP, where he worked on strategy development and market analysis, and research on sustainable nanomaterials. So thank you very much, Leonardo, for joining. I'm giving it over to you, and I'll be sharing your slides, so let me know when you're ready. Sorry, Leonardo, we cannot hear you at the moment. Still not. You are unmuted, but perhaps you can try to change your mic.
Can you hear me now?
Yes, we can hear you now.
Okay, perfect. Sorry for the inconvenience. Thank you very much, Ghost, and thank you to all the European Building Automation Control Association. I'm really happy to be here and to have the opportunity to share also with all of you the results of this research that we conducted during the last year. Basically, it was a 12 months research to understand which can be the impact of building automation and control systems on EPC classes in Europe in particular, but we try to achieve a broader perspective on the automation systems. So we try to focus on both the cost efficiency, the potential of these systems, even from a cost point of view, then evaluate in more detail which can be the impact of these systems on the energy performance of different categories of buildings and different geographical regions. And we then tried to understand which can be the impact of these systems, not only on the single building, but more generally on the achievement of the minimum energy performance requirements, and to understand the full potential of that these systems can have, and to understand in which way we can actually help the decarbonization and increasing the sustainability and the efficiency of the building stock all around Europe. So I already introduced a little bit which is the index of this presentation. So we'll start having a quick review, which was the methodology that we adopted for this research. So we started from data on the average consumption of energy of different buildings of different categories. We considered offices, schools, hospitals, hotels, and apart from the residential sector, so the single family, multi-family houses, some apartment blocks, we try to consider every single every main category of buildings in this research, from both a residential and a non-residential sector. From this data about the energy consumption of these different archetypes of these different types of buildings, we then studied which can be considered the energy distribution, so the number of buildings that there are present in different geographic regions that consume a certain amount of energy. And what we we did is consider the possible energy savings that we can achieve with the implementation of automation and control systems. So, for example, here reported you see the different categories of buildings and the data that we consider as a potential energy savings that can be achieved, in this case just from thermal automation and control systems. So we're talking about, for example, hydronic balancing and thermal temperature control. So we can already see a really interesting element, that's the potential of the savings that these systems can achieve. So we're talking about even a 62% of thermal energy saving that can be derived from, for example, trade sector buildings with the implementation of Class A building automation and control systems. So maybe just a brief introduction. We're talking about the different classes of building automation and control system, and in particular we focus on the more advanced one. So for example, Class A and Class B that indicate a high level of integration of automation systems in a building, considering every single technical building component of with some of the Class A or Class B class automation systems. So we also consider the 4 different geographic areas based on the average weather conditions in order to understand the impact that these devices can have, but not just on a global from a global perspective, but in a more detailed way, how this thermal energy savings can be translated into emission contribution, into EPC classes changes, and even economic advantage considering different areas, so different weathers, different energy consumptions of the buildings. So I think we can let's go to the next slide. So to give you a more detailed perspective on the calculation method that we employed, here is represented the different steps of the calculation. So first of all, we consider the different building types, categories, and we have information about the number of these kind of buildings. We have information about the average energy consumption that each category of building has. What we are missing is how broad this energy consumption is. So if we have, we know that single family houses has a certain consumption of energy, but we don't know how many of these buildings there are for different and varying the energy consumption. So what we assumed is a Gaussian distribution of each one of these buildings categories, and we understood from the, let's say, following the image, the second representation from the left, we try to give a spread of these energy distributions for every building, and reaching in this way the distribution in primary energy demand, in particular, of the number of buildings for different countries and different geographical areas. The idea then was to divide this distribution in different energy classes. Why did we do this? Because basically every single country in all across Europe has different categories, different definitions of EPC classes. So we try to define fictitious EPC classes according to what the EPBD indications could be. So we considered lower than for buildings with an energy consumption lower than 60 kilowatt-hour per square meter. We defined the class as A. Then we considered the 15% of the worst performing buildings to be class G, and we divided the remaining of the buildings in an uniform way to define the remaining energy classes. This allows us not only to have an idea of which these classes, how these classes could be, but also to be able to compare the buildings and their energy distribution across all Europe in a uniform way, in a more holistic way. So I think we can go to the next slide. So I already anticipated that we considered also the cost efficiency of building automation and control systems. So we based our research on different technical reports on the sector. We based it with the help of eu.bac members on real life situation, real life systems. And we achieved in this way an estimate of the cost for the implementation of, in this case, just thermal building automation and control systems over the different buildings types. So just to be clear, I already anticipate these are the costs related to the thermal automation systems. So the automated temperature control and other element of this kind. We referred here to the system as class A and class B of BACS class, but in order to achieve a complete A class and B class, it's not enough just to integrate some thermal BACS of that class level, but the integration of automation system for every single technical component of the building is required. So in this case, we obtained that for an example of a 110 square meters apartment, what we can actually expect is an expense of approximately 1,100 euros, with a possible energy saving of up to 26% on the thermal energy consumption. So this is already a huge reduction in energy. So it's already a significant energy saving for a building, for a limited expenses that is with respect to other systems that a building can adopt for energy efficiency, such as the thermal envelopes, efficient windows, heat pump installation. So these other systems achieve are able to achieve an actually way higher energy saving, an 80% saving, but with a requirement of a way higher initial capital expenditure, so approximately 45,000 euros. So here we can also think for a moment about the importance of the integration of every single system for the efficiency in a building. So integrating these other systems together with building automation and control system can achieve a really significant energy saving overall. So next slide, please. Thank you very much. So we also considered not only let's try to understand which are the cost impacts of these actual savings. So from the data you've seen before, we also try to convert these energy savings into economic savings, and we try to understand during the different years of a lifetime that can be expected for an automation system, so 10 years approximately, how these economic savings actually impact the economic considerations of a BACS integration. So we considered an initial expenditure of 1,400 euros for Class B BACS, initial expense of 2,850 euros for a Class A BACS, so relevant initial cost. But we can easily see that after 3 years, Class B BACS already repaid the investment back. So we have a payback time of this kind of investment of just 3 years and just 4 years for a Class A system, with a net gain from these savings of 5,800 euros over the entire lifespan of one of these systems. So we've seen that's a really efficient way, really cost-effective way of saving quite a lot of energy, and with relevant impact even from an economic point of view. So it's an investment with a short payback time, and that can achieve a good return on the investment after 10 years of a lifetime. Next slide. Then we consider the impact on the EPC classes of these buildings. I've already described how we define these different EPC classes according to what the EPBD could indicate as a EPC class definition. And in this case, we reported the results for the sake of simplicity in a aggregated way for residential and non-residential for all the geographic areas, but we considered the average impact on the buildings. But the detail that we can actually reach is higher, and we can see the impact on EPC classes for every single geographical region. So what we can see here is a quite relevant impact on the transition of EPC classes that the BACS implementation can have. So the idea is on the different rows you can see the EPC class that the building is starting from. So we consider, for example, buildings in F class. We consider the changes in energy efficiency that are possible through the integration of automation systems, and we studied how many EPC classes this building can then improve thanks to the integration of these systems. So what we can see is one that on average the integration of automation system can lead to an improvement of one EPC class. And the other interesting aspect is the difference of this impact between the different starting efficiency classes of the buildings. So if we have a B class building, the possible improvement of class that we can achieve is 0.4 achievement. We try to keep these precise numbers, so now it's not possible to have a jump of just half of a class, but let's say the improvement on the energy span of a single class is improving this of approximately 0.4, like half of a class. So if we consider a B class building, the improvement that we can achieve, for example, in the residential and also in the non-residential is 0.4, 0.3 classes improvement. While if we consider one of the worst performing buildings, so for example in G class building, what we can achieve is actually an even 2 EPC classes improvement. So this seems to suggest that the automation system not only have a really cost-effective way of saving a lot of energy for a building, but it's also a particularly effective solution for older maybe and less energy efficient buildings. So the next results that we consider is, okay, how much would this cost to actually integrate these solutions to the full building stocks in Europe. So we consider in this case the focus is on the non-residential sector. So if we want to adopt automation systems over every single building in Europe of the non-residential sector, which will be the cost and which would be the average improvement. So if we consider, we can see from the results that we consider the number of the buildings that we have for the different geographical regions. We consider then the integration of a Class A thermal automation system. We consider the average EPC improvement for every single geographical region to understand if there are differences in this variation possible, and the cost required for the different geographical region automation integration. So this we consider the average, an average building starting with a D class building automation and control system, and the average of the different starting EPC classes for that geographical region. So we can see that assuming a full adoption of this BACS would first of all allow an average improvement in the EPC class of more than one class, actually. So valid both for Class A and Class B systems, and quite uniform even across the different geographical regions. The cost that we can expect for the integration of these systems, again, for every single building in that geographical area, is varies from 5 to 7 billion euros in case of a Mediterranean region to 20-25 billions for the oceanic geographical areas. So we're talking about significant investments if considered together, but again, for a huge energy saving that can be achieved through this integration. And we can take a look at the residential sector as well. Here, the number of buildings that are affected is way higher than before, than for the non-residential sector. And again, for considering a full adoption of these systems, the possible EPC improvement that we can have is approximately one class, again, similar to before, slightly lower for Class B BACS integration, at a cost of varying from 30 billions in the case of the Mediterranean area, 2 to 4 billion for the Nordic, up to 60-70 billion euros for the oceanic geographical region. Again, the point is this is a significant expense for the integration of BACS to the entire building stock of the geographical region. So we can consider these investment that they can allow an energy efficiency of the entire building stock of the country. So the importance of automation systems is not only in the energy savings in itself that they can achieve, but even how they can help being compliant with different regulation, helping government and different government frameworks for energy savings and improving the building sector. So we consider the impact that BACS can have in achieving minimum energy performance standards. So, for example, for the non-residential sectors, the the target is to achieve a 16% renovation. The renovation of 16% of the buildings. So how much would this cost to renovate 16% of the building blocks with automation systems, and how much would this cost? So the 16% renovation would require 570 million square meters to be improved. That would be achieved with a 4 billion euros total investment, with integration of Class A BACS, Class A thermal BACS. We are talking about a 26% renovation that can be achieved with 1 billion square meters that should be improved, and this would lead to a cost of 7 billion euros. So we can, according to the EPBD, we can consider these costs as total potential cost to be compliant with the minimum energy performance standard for the non-residential sector. We can also have a quick focus on the residential sector. and which is the impact. In this case, the minimum energy performance standards for the residential sectors are a little bit different. Consider in the first step a 16% primary energy demand reduction and a 22% primary energy reduction in the second phase. So we consider how much would, how many buildings and which kind of investment would the achievement of this energy reduction through just automation system require. So the results is that, for example, for the 16% energy reduction, we should improve 25 million buildings all across Europe, and we should integrating Class A BACS in these 25 million buildings, and that would require a 34 billion euros as a total investment and 35 million buildings to be improved in case of the next 22% primary energy demand reduction target, with a total required investment of 48 billion euros. So again, this can be considered as the volume of buildings and the cost that could be required in order to be compliant with the EPBD targets of the minimum energy performance standards for the residential sector. So the key findings, just a recap of the key findings of the research. So we've seen that the implementation of BACS can be achieved at remarkably low cost compared to other technologies of energy efficiency for buildings. So it's a really cost-effective way of improving in a also relatively short time frame for the integration of this system. If you can think about, for example, a thermal envelope installation, this is a quite demanding operation, while automation system can actually be improved, can actually improve the energy consumption of a building in a way quicker way. The building's energy performance improvement is significant. The BACS adoption can lead to even, we've seen quite uniformly, even for the different geographical region, they can lead to at least one EPC class improvement, and can be also potential technologies to improve the construction of future net zero energy buildings. And the impact of BACS is also really important in even in achieving minimum energy performance standards, enabling not only the significant energy efficiency, but even the integration of other efficiency solutions, simplifying the integration of other solutions, leading to the what is called also known as the BACS multiplier effect. So these are the main results of the study, and we try to understand then which is the possible support that can be given for automation integration, automation systems integration. So first of all, incentive programs. It is really important that governments help stimulating this market due to the initial investment that can be a problem for a large scale adoption of these systems. The support of regulatory frameworks is, of course, very important. So, for example, the EPBD, the integration of automation systems in building should also be really prioritized, understanding the real potential that these systems actually have. And it is also fundamental to actually raise awareness about the benefits of automation and control systems among building owners, facility managers, and local authorities and the full government to really be able to help and stimulate the market of these systems in a broader way in order to achieve more efficient buildings in a shorter time frame. So thank you very much. Thank you for the attention. These were again the main results of the study and the possible considerations that that we found after these results. I leave the floor to Gus, I think, for our next speaker.
Yes, thank you very much, Leonardo, and thank you for that in detail look at the study findings. The study will be published on our website and also shared with the participants of this event after the event, so you can take a look at the executive summary and details yourself. But before we proceed, I have to sadly say that Marco from DGNR will not be able to join us. He was not able to resolve the issues with the platform. So before we go on, the next thing I wanted to bring up is a short word cloud for the participants here, so we can take a look at what do you think in the audience, what is the most significant benefit that building automation and control systems can bring to your organization or to buildings in Europe and the projects. So this is a free exercise, so feel free to write whatever comes to mind from the introduction that we had first. So we'll give you around 30 seconds to complete this. We see opportunity first coming up. We see energy savings as the biggest at the moment, and demand side flexibility, make grid interaction possible. I imagine those are together. Growth, future data. So energy savings is really the biggest, together with energy efficiency. Some of you still voting. It's pretty even distribution, but it seems energy savings, and energy efficiency to be the biggest. Now let me just show you the results. So we have comfort and savings, energy savings, and an energy efficiency, as you can see. I will close the voting now. Thank you very much for participating. These results, of course, we will also share following the webinar as well. We'll share the presentations as well. I wanted to still give you sort of an introduction to the policy context, despite Marco not being able to join, since I feel like that might be lacking before the panel discussion. So let me just quickly stop the screen sharing and bring up a presentation in the meanwhile to give you just a few pointers that will be helpful for the context of the discussion. All right. So let me just switch the screens here. All right. Sorry. Can you see the screen or the go to? Just checking. Okay, good. All right. Yes, as I mentioned, I wanted to just give you some pointers in terms of the policy context in case you're not following all the news from Brussels, as you not all of you should. Oh, sorry. And apologies here because this is a bit ad hoc here because Marco, as I mentioned, wasn't able to connect. So a bit on the context and the challenges, as you probably heard several times, buildings are responsible for 40% of EU's energy consumption and 36% of its greenhouse gas emissions. This makes them a really crucial focus in the fight against climate change. And the EU, for this reason, has set a very bold target of a 55% reduction in energy use by 2030 and a net zero emissions buildings from 2050. So these are some of the main goals looking forward to 2030 and 2050. However, this path, of course, isn't without challenges. Automation, electrification, and other things are adding complexity to the building systems. And at the same time, of course, also some of the renovation targets are really ambitious, especially for the countries that might not be able to afford to do large-scale renovations right away. So to meet these goals, we need solutions that are not only scalable, but also cost-effective and adaptable to the evolving needs of our building stocks. So for this reason, the revised Energy Performance of Buildings Directive, or EPBD, is a cornerstone of EU's energy policy. It was published in May 2024, and it sets the framework for achieving energy efficiency and decarbonization goals. Some of the key provisions that are relevant for today's discussion are the introduction of mandates for BACS in large non-residential buildings. So this was a measure that already came in previous EPBD, and this actually starts applying in the member states already next month, which is important. However, the new revised directive has gone a step forward, and on the rightmost side here, you'll see that also smaller non-residential buildings will have to have BACS capabilities by the end of 2029 as well. These capabilities are more explicit in detail in the directive. I won't go into those details here. But beyond this, there's also new provisions coming in through this directive focusing on the smart readiness indicator to measure buildings' intelligence, and also some provisions for the indoor environmental quality, which also relate to BACS and will require certain buildings to have the capability to monitor different indoor environmental quality indicators. Since the directive in general in the EU is not a regulation, meaning that the countries need to transpose this into their national legislation, there is also a transposition deadline, which is set in May 2026. And this is actually where the rubber meets the road, as the national regulators need to try to interpret these different measures and try to provide try to get guidance on how exactly they should implement this in their national legislation, and also ensure compliance, because one thing is, of course, writing this into law, but the other part is also ensuring compliance. So this is the focus of the industry now as well. This is what we have defined as one of our priorities, to support and motivate member states as much as possible to effectively implement these measures to ensure compliance, provide certain tools and explanations also to the relevant stakeholders in order to ensure that the compliance is met. So this is perhaps some of the more vertical measures, but in terms of horizontal or renovation targets, there's also certain renovation targets that the Commission has proposed, and then the EU together has agreed to. So there's certain renovation goals. So by 2030, the focus is on renovating 16% of the worst performing non-residential buildings and reducing primary energy use in residential buildings or worst performing residential buildings by 16%. And these targets are further ramped up to 26% in non-residential buildings by 2033 and 22 to 22% in reduction of energy use in residential buildings by 2035. So this was just to give you a quick, brief overview of the policy measures, just so we are better prepared also to take it to the panel discussion. Again, apologies, it was a little bit ad hoc and last minute for me, so apologies for that maybe not being the smoothest of presentations, but with that said, let me just switch the presentations again and get back to where we were. Right, so we've looked at some of the broader policy context, and we've looked at the study that we are launching today, and now it is time to move to the panel discussion. So I will invite all the panelists also to switch on their cameras so everybody can see you and meet you as well. The session will be moderated by our colleague Gaia Balzarini. She's a recognized leader in energy efficiency and renewable sector with over 20 years of experience in driving sustainability solutions for buildings. And she is also, I'm happy to say, the chair of the eu.bac advocacy group. So with that, I'm happy to hand over to her. And Gaia, you can take over the panel discussion.
Thank you, Gust, and welcome again, everybody. As you have heard, my name is Gaia Balzarini. I work for Danfoss as Industry Affairs Director, but I'm as well Chairman of the Advocacy Group at eu.bac. I'm honored to be your moderator today and to have such a great panelists. So Leonardo has guided us through the study. And we have delved into the potential of BACS in delivering the efficiency improvement of the European building stock. Actually, our building stock is today facing a challenge because on one side we have to ensure decarbonization with energy saving for sure, but on the other side, we need to secure our energy supply so that buildings are strongly correlated with the energy system today. And it's not just about technology, it's about transforming our approach to the energy system and to the way we can deliver sustainability. Imagine a future where buildings, they are not just structures, but they are a kind of intelligent entities that can interact with the grid on one side and optimize the energy flows and the energy use, while at the same time enhancing comfort for users and somehow contribute to the sustainability goals that we have and that we want to achieve. That's basically the promise of BACS. And the study we have been through today is a first step in understanding how we can achieve and go into that direction. We are privileged to have today such a wide audience of panelists and participants. I'm very sorry to listen that the Commission is not able to participate. Actually, we also experienced some issues with a professor here at Politecnico having the same IT issues. So the panelists are a little bit reduced, but I will try to summarize some discussions that I have had previously and cover their part as well. So the study Leonardo just presented us has shown the compelling evidence about the significant cost effectiveness of BACS in delivering our efficiency goals. And as well, he has explained us how BACS can apply not only to very modern buildings, but also to old buildings and to low performing buildings. This for sure doesn't mean that we should not look at the envelope, but still BACS, they are the best solution to prepare the building in a clever way to adjust and digest whatever renovation activity we are going to do on the building itself. To discuss the findings of the study, as Gus has anticipated, we have several panelists, and I want to introduce them to you. We start from women's. So Bonnie Brook, eu.bac Vice President, welcome and thank you for your participation. You are as well Chair of CEN/TC 247 and Industry Affairs Head at Siemens. You will provide us insights into the policy implication and support for effective BACS requirements implementation across the EU. Cecilia, thank you for joining us today from Italy. Cecilia, she's the CEO of Teikos Group, a construction company based in Milano, northern Italy. And Cecilia, she will share with us some practical experiences and challenges that she's facing in implementing renovation in general, but as well integration of BACS into the construction industry. Paul Deverel, thank you for joining today. You are a business director at Future2, and we will discuss with you the challenges that you may experience in the dialogue with end users, as well in the design integration of BACS into your projects. We already have talked with Leonardo, and whenever possible, if Marco will be able to join, we will also have some discussions with him, and also with Davide Chiaroni, who is the lead consultant at MEPS Politecnico di Milano and lead of the study. So again, I'm very confident that this panel will be engaging despite the IT difficulties that we are facing, and will provide us some relevant information. And I think that I'm confident that we will conclude that BACS are a very good option to leverage if we want to meet in a very cost-effective way the European energy efficiency goals, while fostering innovation and sustainability with an industry sector that is traditionally strong in Europe, very strong, very consolidated, and the value chain and experience of the European sector is extremely good and consolidated. So it's a very good opportunity also for the European economy to leverage on something which is currently extremely local. So it's a very good opportunity. Let me start then with the questions. I have tried to rearrange them in relation to the availability of participants, and I would like to start from the field, actually. Cecilia, if possible, I would like to start with you. And I know you have a very good experience in renovation projects in Italy, and I would like to ask you, beside maybe if you can introduce the activities of Teikos Group. And by the way, Cecilia, she's also chairman of Renovate Italy campaign, so she's also representing Renovate Italy today. But but so please let me listen something about your experience in renovation and how you think you are going to meet the EPBD requirements into the Italian market. Thank you.
Thank you, Gaia, and thank you for your invitation. I hope you can hear me well. Sorry, I have some issue with the microphone. Can you hear me?
We do hear you well,
great.
at least myself.
Great, thank you. So I've been listening with a lot of attention to the presentation of the study, because really it's true that working on the field, well, we work mainly with energy renovation in residential sector. All BACS are not so well known. So I think it's, of course, a group of technologies that should be very much closer to the construction industry than they are today. So, well, Tycos is a construction company. We specialize in energy deep renovation. We work with the residential sector, but we're also quite active with schools and education building, almost public building, this last group. So we approach every building with a tailor-made renovation service, because we know that every existing building is different from the other. I mean, of course, there are characteristics of how the building was designed and built, but there are also specific performance that comes from how the building has been transformed in his lifetime. We have to think that almost 85% of the building that we will occupy in 2050 are already built. So well, in Italy, for example, the 80% of investment in the construction sector are investment in renovation. So I think that really the big challenge of the construction industry and all our value chain is how to deal with energy renovation and how to guide renovation activities, not only in order to have more efficient houses, no, that is what the EPBD is about, but also more comfortable to enhance the comfort of our homes and our buildings, the security and the safety, you know, of these buildings. So every renovation project needs to deal with all these aspects. So our approach is also very participative, because we try to work since the design phase with people that lives in the buildings and that use the buildings, because we find out that several times the best technology mix doesn't meet the expectations, because people don't know how to use the equipment that is part of renovation service. So when the renovation is finished, all improvements are not. I mean, they don't reach the expectation, because people doesn't know very well how to use. So we also work in helping people to choose the technology package, and so with some strong awareness activities in order to reach to increase the awareness of people who will use the building, and then also with let's say post-selling service in order to help them to use all this system. So when we can also in our renovation service integrate the substitution or transformation of heating and cooling plant, we used to install advanced thermoregulation systems with remote control. It's true that what I see is that usually BACS come together with the heating or cooling technology. So the architect, the designer who prepares the overall project is not so aware of how these systems can help to make, how can I say, different parts of the building working together. No? So there are specific systems for the heating plant, specific systems, for example, for cooling or for lighting, but normally who try to make all these systems work together is not so skilled in BACS. And I think this is also something we should work on. I don't know if I answered.
That's a very good point, Cecilia, and thank you for raising this flag. It's actually true that when we talk about BACS intuitively, and that's also what we have done in the study, we often refer to the indoor climate, meaning thermal management, but in reality, BACS, they deliver much more than this. So they cover all functionalities of the building, from lighting to, you know, really everything. And only when we are able to make all of these systems working together, only in that case we truly achieve the highest saving. And by the way, we also deliver best comfort to users, and that's where basically all industries focused at the moment. And maybe Bonnie, maybe you have a few words here, because Bonnie has a very long experience from Siemens, by the way, who is truly covering much wider extension in terms of building automation control systems. But as well, Bonnie, she's dedicated to technical standards, so she's very often dealing with designers and consultants and people involved with these standardization bodies. So maybe, Bonnie, you can comment on this point, and then I have another question for you. Thank you.
Yes, so I probably would complement what Cecilia already started talking about the residential sector with the non-residential sector, which is a different type of animal, with the very different types of buildings, of course, that we have. And the main building automation and controls requirements or provisions that come in the directive are related to, or the mandatory one are related to non-residential buildings, have been related since 2018. I just want to remind that actually we are almost in December now, 2024, and by the end of this year, which is another month, actually the previous directive, as well as this one, would require that the non-residential buildings are equipped with building automation and control systems that meet certain requirements. What I would like to underline here, it's not about the mandatory requirements for certain systems. It's actually the functionality and the capability and what they bring in the buildings. How do they improve our buildings? So it is much more important to read the capabilities that these systems, the building automation and control systems, need to meet. So we have in the 2018 version of the EPBD, we have 3 main capabilities. Now we have a 4th one added in 2024 in the recast, and it is related to indoor environmental quality. So we have also this additional aspect here that we need to cover within non-residential buildings. So perhaps I'll stop here because I know that there is a different question that you want to ask me, or start it with the introduction.
No, but thank you. Thank you. It's really important what you have raised. There's an already transposed EPBD from let's say the last version that should already be applied, and in reality from the market we know that it's not really what is happening. So that's an issue. And the question for you, Bonnie, was by the way, from a building automation and control system industry perspective, what steps are necessary to ensure compliance with the current and the past EPBD requirements across Europe? What is that we are still waiting for?
Okay, thank you very much. So let's leave the previous EPBD. Whatever has happened, and let's be a bit more hopeful for the future. So for the transposition of the current EPBD directive, yeah. So what we really hope for is that the member states will transpose, will introduce very clearly the requirements related to building automation and controls in their building regulations. What does that mean? That means it should be clear what is, for example, technical and economical feasibility. This is something that's very open for interpretation. There are certain, there is guidance coming from the European Commission. I will talk about how our industry would like to support the proper implementation. So these requirements for feasibility need to be very clear. So it is not just the left to a building owner or a consultant or someone that operates a building to set certain feasibility requirements. Let's put it this way. So if it is clearly defined to start with, that would be good. Another thing that needs to happen, and I don't think it's only related to building automation, is of course to know your building stock. So the member states need to know their building stock and to have it somewhere, because what does it mean a building with over 290 kilowatts or 70 kilowatts? What is this? So that has to be also very well defined, which buildings are then in scope. They need to be known. A third thing would be to train the people that need to check the compliance, but not only that, checking the compliance is the last step. The previous one is to build the capacity to actually have this this happening on the ground. That means there should be some support, for example, administrative support. Perhaps these one-stop shops in the different member states could also very well be trained in how to approach anything that deals with building automation. Then we have, of course, the point of incentives, but this is something that it has to be a positive incentive, in the meaning that building automation does not need subsidies or that much subsidies. It actually needs incentives to apply, and of course for public buildings you need the investment there. That's clear. But we saw from the study what the comparison is with other investments that need to happen in buildings, especially in deep renovation, of course. So Next step would be to have the tools to do this. And now I will just finish with what eu.bac, the European Building Automation and Controls Association, is providing, is offering in support of the implementation of the provisions. And we know we have from even the previous directive, we have our compliance verification checklist, and I could go a bit deeper. When I say our, I mean eu.bac, not Siemens. So just to be clear, the building automation and controls experts have put their heads together and developed this checklist in the intent to actually support as much as possible. And also eu.bac will have guidelines issued next year, early next year, to support the implementation as well. So I'll finish here, and I'm looking forward to more questions. Thank you.
Thank you, Bonnie. By the way, eu.bac is extremely active in relation to EPBD guidelines and checklists and stakeholders. Feel free to reach out to the Secretariat for whatever support need you may have in the future. Bonnie, there's a question that I think you are the best person to answer about somebody who is not used to the ISO standard that we have used in the study. They basically ask, what is this class A and B BACS referring to? And maybe not everybody fully understands the difference in the labeling scheme of a building and this kind of classification of building automation and control systems. So maybe you can explain a little bit.
Okay, so I cannot explain the difference in the classification, and I think even two member states would have trouble explaining the differences in their EPC classes, but I can talk about building automation. So just going down to straight to the question, the difference between class A and class B. Class A is a high performance building automation system, and class B is an advanced performance building automation system. So what does that mean? What do we have more? I think the very important class for the participants to remember, or for anyone actually dealing with the standard ISO EN ISO 52120 part 1, is that class B, building automation and control system, means that you could have demand-based control in a building. This is what it means. And what that means is you actually have room automation, let's put it this way, either room or zone automation. And this automation allows you to monitor and adjust the supply of heat or cold to this specific room or zone according to the current demand in this room and zone. So this is the most efficient way of using the energy while providing the indoor environmental quality that is necessary in this room or zone. This is the definition. So actually, building automation and controls always deals with comfort is only one side of the indoor environmental quality, because there are other, as we know, after COVID especially. So we know there are different aspects of indoor environmental quality, but the system traditionally provides that, actually maintains the conditions that the building is requiring in this, so that the room is requiring. Which means, for example, a very simple example, if you don't have anyone in a room, you don't need to have the lights on. That's a very, very simple one. So this is class B. This is the one that is important because we say with the EPBD provisions, this class B needs to be reached. With class A, what we have is the technical building management component, which is much stronger. It's actually the highest that you can get, which means you have all the systems, all technical building systems in the building, integrated in BACS, and actually managed without fighting with each other, for example, heating and cooling. That's one example. So there are the interlocks. There are also advanced features, control functionalities, like not only energy monitoring, but also diagnostics, forecast. So this is where all the FDD part comes, for example, fault detection and diagnostics. Sorry, that's a technical abbreviation. I saw there was a question about that, so I would like to cover it if I can here.
Yes, please.
Yes, so really class A is the highest class that could be achieved through a building automation and control system, basically. It doesn't have bells and whistles. It simply controls the building in the most optimal way. And the most optimal way is defined by the designers of the building or the owner of the building. I mean, how do they want their building to operate? And then the most optimal, efficient way is to actually base it on the demand, while ensuring the comfort of the occupants. This is what the standard is doing or describing.
Thank you, Bonnie. Thank you. To summarize, basically, by achieving the highest BACS class, we basically ensure that the very, very, very minimum energy effort is used to meet the user requirements. Not a fragment of a unit more than the minimum, which is satisfactory for the user. And that's why BACS are efficient.
But maybe if you allow me just one more sentence, you're absolutely, it's perfectly well said, what I heard. It's just that, and how do we know this is because you monitor through the system what is going on. You get all the different feedbacks. You also diagnose the data that you're getting back, and you can detect deficiencies in the different systems as well as the building automation system, and you inform the operators of the building that there is a problem.
There's also this other aspect of efficiency that is delivered by BACS, because basically the predictive actions, predictive maintenance is also something related to being efficient. It's not only the energy consumption that is saved, but also the effort around the building that is saved. If you can anticipate some issues or fix troubles in advance, that is as well energy and resource saving, and that's something that's not calculated in the study that we have delivered, but that should be taken into account, plus everything which is related to living in a healthy environment for people, with the impact on health and saving in that direction as well. So these are other perspectives that should also be included into the discussion here. Thank you, Bonnie. I'll maybe come back afterwards, but I want to have and raise a question to Paul. Nice to talk to you, Paul.
Hello.
Paul, customers, and misconceptions, and how difficult and what are challenges in dealing with the application of solutions for renovation and BACS, specifically with building owners. How do you normally address these issues or concerns by these kind of stakeholders? Thank you.
Yeah, thanks for the question. It's certainly a lot easier than it was 5 years ago, and that's positive. I can definitely say that what our company does is we design. Firstly, we maybe have to troubleshoot, but then we design and we install building automation systems or building management systems in buildings. And we also, so we have two departments, BMS or BACS and HVAC. So my colleagues are BMS engineers and HVAC engineers. So we sort of bridge quite a lot of the building systems and energy consuming systems. I think that if you mentioned already, and Bonnie and Gus already mentioned several points, which maybe I'd like to touch on. One of them is, it seems that EPCs are going to become, let's say, the focal point here. And I'm glad to hear that, because I think, touching on your question, a lot of building owners and property managers are really lost in the fog, because there has been so much, guidance and discussion about this, not only with the different iterations of the EPBD, but also, of course, from different certification standards. So LEED and BREEAM, and then we have, of course, discussions about the minimum energy performance standards, then building renovation passports, EN 52120, and it's really quite hard to follow. And even for us, we have very often over the last few years discussed at length, how do we interpret the EPBD directives and move those into practical implementation and discussions with the actual building owners and the property managers and facility managers, which we typically speak to. So if we're saying, EPC, it looks like from our perspective as well, and judging by the comments made in the last few months from all parties, that EPCs will become a focus point. And I think that's a positive thing, because it's something that I think many people understand. You don't need to be a building automation systems expert or an HVAC expert to understand the A to G rating, and we see it all on our washing machines and fridges already for many years, etc. So I think that's a good start. What I would maybe like to see, or we would like to see, as we are actually doing the implementation, and as you mentioned, we are sort of explaining to clients who are often non-technical, at a non-technical level, which is really my job as a business director, why they should implement, for example, a B-level BACS over a C-level BACS. And then I have to explain what the ABCD means. And then often a question will come back with, well, how come BACS is only A to D and not A to G, right? So then it starts there. So what I think should happen, and we read and we see a lot of EPCs from the buildings that we work on. By the way, we mostly are active with renovation or modernization of existing buildings. Sometimes we work on new builds, but I think today we are more or less focused, let's say, on the renovation of existing buildings. And by the way, we only do commercial properties, so I can't speak to the residential part. But when it comes to commercial buildings, when I look at EPCs, granted, I am not an energy auditor, but having discussed it also with our BMS engineers and HVAC engineers, they look at an EPC as something which is sort of, I shouldn't say this, but the only word I can find is a toy, because it doesn't go into enough detail to inform them what the actual performance of that building is. So we have a great example at the moment in Bratislava in Slovakia. It's an office building. It's quite old. It's about 20 years old. But that building has very, I would say, being diplomatic, the performance of the building is poor. However, the EPC rating shows a B class rating for that building. Why is that? Well, the rating was done after COVID, when people started coming back to the office, but it was based on a kilowatt hour per square meter per year value, which it's not. If the building was fully occupied, that building would in no way achieve a B class rating in EPC. So I think when it comes to kilowatt hours per square meter, there is a question mark over that. I will try to cut this a bit short, but what I would like to see, what I think we would like to see is when an EPC is evaluated, who are the evaluators of the EPC? Is there somebody there involved who is, let's say, an eu.bac or a BACS assessor, accredited assessor? So what Gus and also what Bonnie touched on is we would like to see guidance. We would like to see guidance for us as installers, but also guidance for the clients that we.
Thank you. I think, do you hear me?
Yes.
Good. I really think that what's also interesting in the deployment of BACS is that they can actually deliver real-time information about the real consumption of a building in this specific user condition. So having a match in between EPCs and the measured value by BACS would also help, first of all, in the understanding of the building stock, the real building stock, and not the nominal one, which is this kilowatt hour per square meter per year value that you are mentioning, which is a kind of theoretical value, right?
Right.
And at the same time, BACS will also help, for example, governmental stakeholders in keeping track of the upgrades of the building stock,
Exactly.
and to keep the trajectory that we need to deliver to meet the sustainability goals and efficiency goals. Without an information which is ground-based, we will be blind over the target. So
yeah, well,
that's
theoretically,
also...
it should all be automated. It should be, but as we see, as Bonnie mentioned, the difference between a C and a B level, enabling that, as you're talking about, let's say automation or enough data gathering and quality data, that then those kilowatt hours per square meter per year are relevant, because we see a lot of buildings where maybe even the building owner thinks that everything is connected, but for example, the tenant areas are not connected. So the IRCs are not connected to the central BMS. And as you mentioned about room control, the BMS is then getting substandard data because maybe it's getting data from main building systems like air handling units or boilers, but it's not getting feedback from what is actually happening in the building. And that we see across many, many properties. And definitely that's an issue.
Yeah, yes, agree. And by the way, there's a definition about low temperature readiness of a building, meaning the ability of the building to work with, for example, district heating or with the heat pumps, that is deeply related to the ability of the room controls to communicate with the heat source properly to minimize those temperatures. So that's also where having a holistic approach over BACS would help in minimizing those losses. We have, I think, covered pretty well the non-residential application, but for sure residential, and even not only the multifamily houses, but in general the residential sector is also pretty relevant also in terms of coverage around the building stock. Cecilia Teikos is pretty much involved into residential sector as well. Maybe you have some nice story to tell us we've discussed, for example, highly efficient buildings where you told me users are spending more than expected, and maybe you can tell us a few words about that specific case, but also if you have some nice story to tell us about some other applications and some comments around the residential potential of building automation control system according to your experience. Thank you.
Sure, thank you. Yes, we were talking, I think the day before yesterday, about this experience we had through research and development project financed for Lombardy region. So in these last 5 years, we have renovated almost 60 residential buildings, almost with passive technology, so thermal insulation and changing windows replacement, because lots of these buildings, maybe they had district heating or centralized heating systems that were in common with other buildings. So we could not include the specific work on the heating system. So what we did is to install a system which recorded every 15 minutes, measured every 15 minutes some measures in order to evaluate the comfort. So specifically temperature, humidity, and the presence of CO2, so comfort and air quality. And our surprise was to see that in winter time here in Milan, all the buildings are placed in Milan. In winter time, we had temperature inside the flats between 24 and 26 degrees. Of course, from one side, the inhabitants were quite happy because they asked for our services because they were cold in winter, not specifically people, maybe people that used to spend a lot of time in their houses. But on the other side, they were quite disappointed because our promise of energy efficiency, of course, was not reached, because before the intervention, they had like 18, 19 degrees in their houses, and after 24, 26, of course, the target of energy efficiency, energy saving was not met. So we started to propose them to some kind of control. Well, first it was through an app where they could have checked the temperature they had in their house and put them near the ideal temperature, and the app had them to calculate the saving that they could have if they spent and they maintain temperature to 20 degrees. But there were very, very few families who tried to use the thermic regulation control, which was really very easy to use in order to lower down the internal temperature. So, of course, we always say that the main barrier to energy saving is cultural. No, it's not technological, because, I mean, all industries have a lot of solutions that are not necessarily so expensive. And of course, moreover, in this case, where they already did the big investment, no? Because thermal insulation used to be the most important investment. So the building was prepared in order to enhance energy savings, no? And to really to measure them. So I think that this part, which is the cultural part of energy saving and also comfort in houses, because I think it's not so good to have 26 degrees and then to go on the street and find that there are 3-4 degrees. No? So it's really important. And then the other thing I wanted to point out, and I don't know if Paul has the same experience, is that somehow from in the residential sector there is this idea that I mean, renovation is like the hardware, I would say, and in the hardware there is the new boiler, maybe there is insulation, there are the windows, but all control and or BACS are a kind of software where I can buy it in another place, decide if I want to install them or not. Maybe I can install it just in my rooms, but not in the whole process of the energy management. And I think this is also an issue and a cultural barrier to the real implementation and enhancement of these systems, because of course this idea that I can buy 2 sensors on Amazon and and I have done with my control system of for energy efficiency is an idea that is quite dangerous. And the last thought I wanted to share is that I really think that as building sector, we are now in a kind of crossroad, because if we do give this cultural step also, I'm talking about all the value chain in the construction sector, to integrate BACS in the hardware, we will be more able to maintain an important part of the added value of other work. But if finally the market goes to this kind of plug-in solutions that are completely separated from renovation works, and so from permissions from the authorities, or all the bidding process that is behind the renovation work, I think we may lose a very important opportunity. So I really think that the construction sector should be much involved and collaborative in order to bring on the ground BACS systems within important renovation projects, also in the housing sector and in renovation sector. I mean, because this, yes, it happens on commercial buildings, but in residential sector, there is a bit this separation that I think is quite dangerous from our side, at least.
Thank you, Cecilia. I really like this perspective and the way you describe the approach to BACS, that they are perceived as a digital tool only, that is completely separated from the renovation itself. I really like this, and it's eye-opening somehow to me, because I think that's a point where we as a sector should invest a little bit more. Paul, it's slightly easier maybe in the non-residential sector, but I would like to ask if you can comment here, because.
Sorry, what was the question again? Just to elaborate.
This effect that BACS are not really incorporated into the renovation project or design of a building, especially in the residential sector. Maybe the non-residential sector is more used to integrate smart solutions into the project. Thank you.
Yes. Was the question for me? I suppose. Yeah. Okay. Yeah, I think that it's become a lot better. My job is a lot easier than it was 5 years ago, where I had to really try to sell the whole concept of having a building automation system or an upgrade to building owners, because as we are all as humans quite aesthetic. It's better to maybe, or it was better to focus potential investment as a building owner perspective on making a nice reception with nice chairs and things like that, and upgrading and spending money there, as where building automation, of course, and HVAC to a large extent is invisible. And so I think we had to get over that barrier. But I think to be a bit more positive, I think over the last 5-7 years that has changed dramatically, and now we see definitely focus on the non-aesthetic part, and that's driven, of course, by tenants. We have a number of buildings where the tenants are really pushing landlords in the direction of, okay, how are you going to upgrade not only, you know, the elevators and the reception, but how are you going to upgrade the cooling, heating, ventilation, also the automation system. It was quite surprising to me, actually happened this week, that I found out that one of our clients, which is the building owner, has actually pushed this forward because pushed the upgrade of the building automation system forwards, because one of the major tenants, it's an office building, in that office building has actually demanded it. So we are seeing the drivers coming from different angles. So back to the question, if I understood it correctly, I think that now it's really not only a case of when a building renovation is happening, that it's you know, reception and new elevators, you know, maybe solar panels and maybe some EV charging, which is quite sexy and it's quite, let's say, topical at the moment. I think it's luckily moved a bit further than that, to the point of, okay, we understand our building needs to be controlled by some type of automation system, and I think the market is also understanding the great advantages that the building can achieve, as you said, not only from an energy savings perspective, but also from a reduction of maintenance costs, future-proofing the building, providing data to regulatory bodies for non-financial reporting, etc., etc. So I think, I hope I answered the question sort of properly.
You did, thank you. There's also the sustainability reporting perspective that's becoming relevant today. So that's also where BACS can deliver information and value, I think. Thank you, thank you. We have 10 minutes to the end, so I would like to raise a question to you, Leonardo, unless Davide has been able to join the call. No, so I have a question for you, which is related to the point I already somehow touched upon, which is the BACS industry in Europe is pretty consolidated, and the value chain is pretty strong, and how investing into BACS can contribute to the European economy and value chain, to local supply chain support, and also job creation. Thank you.
Thank you, Ray, for the question. First of all, of course, we're talking about really structured value chain in Europe, so that can really give some contribution. First of all, from a purely economic perspective, having relevant savings from an energy point of view, it's also translating in an economic advantage, so a more efficient way of consuming energy. So that would allow lower costs to achieve the same results. So positive aspect for everyone. It can, of course, stimulate local supply chains in the production not only of BACS. We have, of course, solid construction builders and technology provider in Europe. But one of the most interesting part about this is probably what I already mentioned, the multiplier effect of BACS. So the possibility of stimulating other technologies adoption together with BACS introduction. So introducing automation and control system that gives you better data on the energy consumption of your buildings, that maybe can allow you to increase the interest of people in the adoption, for example, of solar panels or other efficiency solutions that they can monitor and control in a really simple way at the point when there's also the adoption of this kind of automation systems. So it's not only the local supply chains related to purely the automation system that we're talking here, right? There's this possibility of stimulating the entire value chain of basically every efficiency technology for buildings in this sense, with of course the correlated new job opportunities. We're talking about the highly skilled technicians, we talk about producer, we are talking about installators, so people that can actually maintain this kind of systems. So even a new set of skills that can also allow these kind of solutions to be integrated in a way more efficient way together with the other efficiency technology, in a more integrated way with respect to what is currently done.
Thank you, Leonardo. A disclaimer from myself, we are sitting in the same room, and maybe you, thank you. So we disturb each other somehow, but in the screen we are opposite the way we look at each other, so it's pretty funny to take lead in the discussion here, because somehow I look at the screen and somehow I look at him at the same time. So sorry for this. I have several questions that I have received, some of which I have covered, some others. There were many questions related to the to how BACS can be better weighted into the EPC's schemes across Europe. That's an open question. If you have any suggestion that, and if anybody of you has a point here, I would like to hear what is your opinion. For sure, the weight given to BACS should be better in place in the EPC's schemes, but maybe something more.
Maybe let Bonnie take that one.
I've been having discussions with different stakeholders in the construction industry about the EPCs. So my understanding is that the EPC assessors, auditors already take into consideration building automation and controls. And if any of them are not yet doing that, then they should be taking it into consideration, because building automation can offer a lot of potential for actually improving the rating of a building, as we already have been discussing in the last couple of hours. So with changes even in the software only, we could achieve a lot. And also, unfortunately and sadly, there are buildings that have building automation and control systems, but they're not used or not used properly, not used to their full potential. And I can see Paul nodding, and I know this because this is not my first job in the industry, and I have seen it in buildings. So we need to raise the awareness, as it was one of the conclusions of the study, train people, educate people. And I just want to go a step back just to the question on the how to ensure the compliance for the member states. They have to have information campaigns. They have to inform actually the building sector about the provisions in a very simple and clear way. and involve them, of course, engage them. So I can see Gus on the screen. I suppose he will raise his finger now and say, okay,
yes.
that's but
No.
yeah, that's my last word.
Thank you, Bonnie. Closing remarks from Gus, I think, and thank you to the audience and to the panelists meanwhile.
Thank you very much, Gaia. Indeed, really nice discussions and many questions. As you said, some of them answered, some of them I think still remaining. So it's good to see that there's active engagement. Perhaps before we conclude, before everybody leaves to their daily jobs, I just wanted to conclude with an opportunity to the audience as well with the last word cloud. If you're still here on Slido, if you could also try to describe the ideal building of the future in a single word, what would that be for you? Just an opportunity to conclude today on a high as well, perhaps. I see it takes time for people to think of one.
Not easy in a single word.
What would be your word, Gus?
I don't want to express bias. I'm representing different companies, different interests. So connected seems to be a good one. I think nobody would disagree with that. Health, absolutely important as well. Zero energy waste integrated into smart infrastructure, efficient, low energy, smart, autonomous, SRI, intelligent. So different aspects. Thank you very much for that. With that, we will conclude. I just wanted to also invite you to continue being engaged. As we conclude today, of course, thanking all the speakers and panelists for your valuable insights. I think you underscored the crucial role of BACS in the energy transition through improving the EPCs, but also you touched upon many other things in the discussions, I would say, both on the multiplier effect of BACS, on the different functionalities that it provides beyond energy efficiency, actually. You highlighted also the need to actually implement the existing BACS requirements, which, as was pointed out, sometimes today already come into effect by the end of next month in the member states. Furthermore, you also raised the lack of clarity that exists in the complicated legislative and standardization landscape, as well as some cultural barriers that perhaps are out there. So I think this is where all of us as stakeholders can play a role to motivate and support this effort of enhancing the visibility of BACS and the implementation of them. So thank you for that. And to everybody in the audience also, thank you for the engagement and taking your time to join us today. I encourage you to take these ideas and solutions with you wherever you're from, back to your organizations, and continue the dialogue with us as well. For those of you who might have additional questions, feel free to reach out to us, the eu.bac Secretariat. And as a follow-up, we'll of course share all of today's materials, recording, and as well as study with you in the coming days. Finally, special thank you to my colleague who's in the room here as well, Kieran O'Regan, who helped with the efforts of organizing this session. We look forward to seeing you soon around in different events and continue working together for a smarter and decarbonized Europe. Thank you all, and have a wonderful afternoon.
Thank you.
Thank you. Bye.
Thank you. Bye.
Bye.